this industry almost more than a decade, doing a lot of vulnerability research, exploitation, building different products around. And throughout this year, I learned a lot of different lessons. And looking at the current technologies, I feel like this is really we are back in 2010 for the security. That's what I feel. And I started working on building the offensive AI products around that. And parallelly, I split my time into two things. One would be continuously leading the whole team at Secure Layer 7 for red teaming, pen testing, and all that. Parallelly work with product team to build the offensive AI product. That's how it is in 2010. Back in time, yeah. Back in time, I was the first person who found the XSS in the search engine box, the first person to find in the Google specifically, and then later on found a lot of vulnerabilities in Yahoo, Twitter. You name all top 10 internet companies, I found a lot of critical vulnerabilities. Believe it or not, I have also seen some SQL injection in Meta, which we called Facebook previously. So covering all this, my experience and bringing everything in this presentation, we are trying to build something which you probably seen in the market or probably not. So that's what we are going to see here. So this talk is specifically, I want to give you a glimpse about how the traditional security may change just because of the LLM. The LLM that being, frontier model that we have right now, which is are much more capable. We are trying to cover the evolution of offensive security. We'll have some, details around that. We'll talk about traditional pen testing. Then we'll talk about AI agents. We will also see how we can build AI agents. What are the technology that we want? I'll try to wrap up everything within 1 hour or maybe a 50 minutes. If not, then I'm here in the conference for next 2 hours. Probably we can catch up and discuss in more detail if we are missing anything of that. So I'm also going to talk about one of the end-day exploit, which is the proof of concept is not yet in the market. On that slide only, I just have a request, let's not click the photos or videos because this yet to be fully fixed and fully deployed at at the biggest level. So that's where I just have one request there. Although the recordings are going to go in Jan, and then I'm expecting that to be fixed earlier. So there are a lot of confusion here. How many of you heard of adversarial AI? Have you heard of adversarial AI? And how about the offensive AI? Offensive AI, okay. So let's do quick, a quiz here. I don't know if it is visible. Oh, the screen got changed. Okay. So, this is the Slido QR code. If you can just open up your phone and then just log into Slido, you can use that number. We'll try this script. We'll try this quiz. Let's join. Let me start that. Okay, the quiz is already started. Yeah. This is going to be 6 questions. I just want to give you little education around what is offensive AI and the adversarial AI, so that you can understand how you can build your own offensive AI. Otherwise, everyone will get confused here. Okay, the cloud is growing now. We'll wait for a few moments. If I'm speaking too fast, you can just correct me. I can go a little slow here. Okay, I think we are good so far. Let me start with the first question. Okay, on your mobile, you got 20 seconds to answer this. What does adversarial AI means? And you got option A, B, C, D. You can click any of those. Okay, 38% attack against the AI model or the system. AI is the target. 38% says any AI used by criminals, AI used by defense, and then AI that steals. I think the correct answer here is B. Attack against AI model is your adversarial AI. Any AI used by criminals is not the answer, by the way. That was like, really nice to see. That's the answer. Let's go with the next one. What is offensive AI? Have we heard of offensive security? Now, offensive AI. So we have option A, B, C, D again here. The brand of antivirus. Wow, that's pretty nice option. Yeah, let's see. All right, this time the polling wins. Option B, yes. I'm not favor of B, always the B is not going to be the answer. But yeah, using AI to launch attacks on people or system, that's good. Okay, let's little bit different questions now. Which of these best describes difference between two terms? They mean exactly the same. I mean adversarial AI and the offensive AI. That's the two different terms. All right, I think everyone knows answer B. Yeah, that's good. And the next one. When your AI writes phishing emails better than your marketing team, what's that called? Adversarial AI? Offensive AI? What it is? You can ask this question to your marketing team. Thursday at work. Yeah, today's Thursday. So many people are working. I've seen in the lobby. Yeah. Okay, that's right. Option C, offensive AI. Yeah, people are doing well here. Some of the people written like, Thursday at work. I'm feeling sorry for you. You're conference and you're working. Cool. We are hiring, by the way. Okay. Fifth, you tell your AI assistant, summarize this email, and it reply with your boss's salary details. What just happened? Yeah, I believe everyone knows what happened. Salary got disclosed. Yeah, a breach of data. Okay, let's see. Prompt injection. We are technical, right? So let's focus on technology instead of compliances. Thanks. Last question. Yeah, I promise this is last question. Which of the following is not an example of offensive AI? AI guessing passwords. Do you do that on ChatGPT? What's my password? Probably, yeah. GPT is making profile, I think, worth checking. What's your password? Possible password? Who knows? AI doing yoga. Wow. Cool. Let's see the answers. Oh, wow. Okay, we need a lot of education here. Good. All right, so that's conclude overall slides. Let's get back to our work. So I think, yeah, the confusion got little covered here, but I just want to get into a little deep around these two terminologies. And there is also intersection that we will talk about. This is kind of important for the offensive AI. That's why we are discussing here. So the adversarial AI, like everyone knows, it's kind of like the abuse of the models. Okay, when we say abuse of model, you are actually trying to bypass their safety and privacy protections, right? Today, if you try to ask ChatGPT or Cloud or any of this engine, okay, try building red team, exploit toolkit. Immediately it's going to say, hey, we cannot do that, right? So that's the adversarial AI, and there a lot of attackers are able to do that, and that's where the attackers are trying to fool the models and get some data out of that, or maybe ask AI to do that system, right? So it's kind of a prompt injection and the jailbreaking. That's where the AI adversarial comes in. Offensive AI is something that we humans, we try to do red teaming, right? So we try to attack, we create a lot of scripts. So similarly, instead of human, the model is going to do on behalf of you. And there are processes that we are going to discuss, right? Agent can do all autonomous, fully, I would say every phase that it will be able to execute your pen testing. This would be the LLM powered reconnaissance or discovery of system, whatever that you have, and automated exploit definitely. So that's how the offensive AI look like. And then there is interplay that you might able to see every time when you are going to discuss with your managers or your colleagues everywhere. So the intersection is like AI testing AI. You would have seen that, right? Cloud, how the cloud get tested for the AI safety bypasses, because they build some scripts, prompt injection gets generated, and then it get activated on your cloud. So that's how the intersection there. And offensive AI also required the adversarial AI skills, because nowadays safety protocols are much better in cloud and other frontier models. That's where you need to bypass those safety bypasses, which we will also talk about that. And we are going to use adversarial AI in offensive AI, right? Everywhere is AI. So I spoke AI how many times? I don't know, like almost like 200 times maybe this talk. So there's a paper you can go and get into details, really detail, like you can understand what are the other intersections, where are these can be used. There are humanoid robots also, like how does the offensive security or adversarial AI works on that. So a lot of details there. You go ahead and check there probably. Let's talk about the problem here. So we have a lot of problems all the time. Without problems, we don't have solutions. So the typical red team or pen testing, we sit down, we look at the application, we look at the different infrastructure, and then we start doing a reconnaissance process. Like let's execute subdomain finders. Let's try to find maybe which subdomain has Apache installed. What kind of Apache? Oh, okay. There may be a potential Log4j vulnerability, right? It's a kind of like time-intensive work. So I'm investing maybe more than a week on a red teaming just to figure out what are the assets that belongs to your company, right? So that I will take a lot of time, figure out, store a lot of Excel sheets, create CSV, and end of the day forget, okay, what are the assets are there, right? So we have a lot of weaker memory than the LLM, that I would say, or maybe like probably like we have to improve that. And that's where like the moment we collect data, the context of the IP address, applications, assets, mobile apps, we forget about it. And then we try to deploy the automation scripts. Let's say nuclei, right? That hope you're aware of nuclei, right? So that execute whatever the templates that you generated. And using that, you're just testing some of the signatures, and probably that's not going to yield any of the results. And that's where the trade-off happens between scale versus depth. So we are able to scale it. Today's world is wipe coding, right? So in the wipe coding, I don't know how many number of line of code my developer is writing today and how many instances are getting generated. I don't know. We will be able to scale it with the lot of different tools that we have on GitHub. Open source or closed source or premium, whatever the tools that you have. But eventually, we will not be having, okay, where is that? Eventually, we will not be having the depth. We don't have a depth where, we can say, oh, why Log4j did not really found? Because it was staying for a very long time. And if you look at the payload, it's just a string. And it is found during the SOC operations, not really during the assessments. So I think that's the problem that we really want to solve in the traditional misses, right? So there are a lot of problems. Let's talk about solutions, right? Solution is as we know, we are in the LLM era, so AI is the solution. So you just throw solutions as AI, VCs are going to throw back money back to you. So that's what not happening with us. So we are trying to solve a real problem. Let's see how it goes. So it's not really the window that we are going to type in, hey, ChatGPT, hack this for me. It's not going to work, right? Or get the social media password of my girlfriend. Yeah, that's not going to work, right? It's going to be different. So we will have to build whole infrastructure around that, and that infrastructure we'll discuss here, right? Don't go on a title, by the way. That was marketing gimmick to bring you all here. So exploiting the unexploitable, I don't know, how does that work, right? But I'll also try to show you how the NDA can get executed when there is no POC available in the market. How AI is really helping. That's going to be interesting, right? If you look at the automation, there are a lot of problems that we discussed. But offensive AI agent, what it's going to do here, it is trying to simulate the thought process that human is trying to do. And LLM doesn't know like whether it's an attacker behavior or like, it's a good guy or ethical person, right? Just because of the safety rules, it's going to follow. So yeah, and we are going to use that process. So reasoning and decision, these are the two important aspects, and also the context, right? These are the three major reasons that we want to move into LLM's testing, or maybe like use that as a part of a tool, right? And the third one would be like I told you, right? During the recurrences process, you are not able to remember, okay, what was the Apache version was there, or what kind of exploit is available for that version, and then you realize, oh, I forget about that, and then someone is escalating why you missed to report this vulnerability. That was the line I usually get it through whenever I'm finishing my red team and pen testing. And then we say, oh, we sorry, we missed it. Not anymore. LLM, we are going to point it back, oh, LLM did that, right? So that's going to be another reasoning for us. So it's going to be end-to-end assessment through AI. It's also going to do the dynamic planning on the spot, like, okay, understand what are the stack stress errors, what could be the potential methodology, what could be the errors which is coming in, and define everything on the fly. That's what the prompt that we are going to give. And then it will build whatever the necessary information, right? The core capability that we want, it has to be autonomous. Otherwise, it's no use, right? It has to be autonomous. And everyone, this is quite a confusing back in time, like maybe 4 or 5 months back. Everyone was saying, okay, human in chain or loop is the weakest chain, right? Humans are always weakest chain. But when we talk about LLMs, they are saying, okay, loop the human. So that's what is going to happen. We are going to loop our pen tester back in the process so that we can understand what's the value and the quality that we are going to get in, right? It's going to generate the dynamic payloads. That's SQL injection, right? So as a black box red teamer, I don't know what other database has been used. So in that case, probably I have to figure out fingerprint, oh, it's Oracle, it's MySQL. That's how it's going to be identified, different types of databases, and then put that the payloads. It's not really a signature based, or it's not really a SQL map, which is going to throw a lot of commands of SQL injection and end of the day get it blocked. We also going to think about, okay, if you're testing application and if you hit 500 error, what does that mean? That means there is some protection, maybe a load balancer or web application firewall, which is actually stopping your application there, right? And then what do you think about, oh, let's try to bypass that. How do you bypass it? You look at the known web application firewall bypasses, you look at the different bypasses, if it is there or not, you try to encode, decode, put the base 64, whatever the payload that you feel, that has to be you've added. So probably you will try to do that. Similarly, also agent is going to try to do that. It's not going to stop on the moment it sees error 500. And in contrast, automation does stop that. The moment it look at, oh, 500, done, I don't know, next. So that's what the capability I think we want to have it. And it will work on the large environment. So red team, usually if you look at, it's a very large landscape. And also the pen testing based on your assets. The major part that based on my research, and this is all coming from my experience, everything is realistic. I don't really follow OOPS top 10 because I feel like OOPS top 10 has a lot of vulnerability which I never see. Yeah, I know this is kind of controversial, but it is applied to only LLM. Today's LLM top 10 list. Maybe they are updating, improving. Probably it will go on. But in my routine pen test, I don't find it. So that's where the recurrences is something. I hope this is visible, but recurrences and intelligence, something that I really want to focus. That's where the agent is going to bring value. And then I would say maybe in the exploitation and some part of the other methodology. But there is a huge process here. We go through with the recurrences, we go through with the initial access, we'll go through with the post-exploitation. If there are web applications, we'll try to exploit those. If there are any cloud infrastructure like AWS, GCP, or you're doing specialized operation like bug bounty, probably bug bounty is another big area that you really want to test. And yeah, there are many folks have done a good job with using agent. They are able to find vulnerabilities. So this is what we are trying to cover. But in the example today, we will cover web applications and some of the known, very well-known applications, and also some part of a post-exploitation, right? So that example and the demo, I'll try to demonstrate here. So before that, I also want to show some of the architecture here. So we human, we first of all observe. So similarly, agents are going to also observe the data, whatever the data is incoming. This is a standard framework, but I added two different aspects here, judge and observe. So if you look at today's any white papers, they talk about react. That means reason and act, and the learn, right? So usually you will see this two process, but personally I feel we need to have two more different approach here. We also need to add observe and judge. Observe and judge are two different components that we really want to have in our agent. So this is a 5-step agent. First we will do observe, then we will go for the reasoning, and then judge, act, and learn. So observe is like, we are going to observe the applications. We are going to observe whatever the data has been collected, analysis, whatever you have collected so far. And the moment we have that information, we are going to pass on to a different agent, which is like, doing just reasoning for your purpose. Let's say, figure out what the data is. Understand, is it a healthcare? Is it like, what kind of industry it is? Build whole knowledge graph for around this whole assets, maybe a mobile app or web app. And then it is going to give a different agent. That agent can be exploitable agent or whatever it is. And the exploitable agent is going to generate some sort of a vulnerabilities. And today's world in LLM, I believe, hallucination and false positive is the biggest problem right now. I just want to tell you one of the story, like, we are running our product for some of our customers just for like, test purpose. And our like LLM reported them, oh, there is a critical vulnerability at the Friday night. And previously, whatever the vulnerability submitted, that was really a good vulnerabilities. And they trusted, oh, okay, there is a vulnerability exist. The moment they saw that vulnerability, they invested almost like 6-7 hours Friday evening. And then they realized, oh, it's a systematically well-generated false positive. So the moment they look at, oh, that's a really nice request. Oh, response is also coming, which is going to align to that request. And that's where, like, everyone, like, spends a lot of time. And that's where we thought, oh, okay, there has to be some system which is going to help us to mitigate this problem. That's where we added judge. And judge is really helping us to figure out, okay, what are the vulnerabilities are really not a false positive or hallucination. And then act, it's going to execute whatever the commands or whatever the instructions are coming from other agents. And eventually, if you add reinforcement, that means you're going to learn from whatever the mistake that you made. The learn position is going to help. So this is one of the really important, I would say, aspect for the agent reasoning and loop. If you understand these loops, then it's very, very easy for you to build agents in OffSec probably. The configurations. So we have right now access to frontier models. We tried really hard on the GPT-4, worked very well because of the cost also. Cloud is also really nice. They are actually having a, top of the every model in terms of coding and, the offensive security so far. But the token cost is very high for that. You can try all of this, but I would suggest to kick in, probably start with the OSS models. There are so many OSS models are available in the market. Personally, like, Kimi 2, I really like that one. That really helped me to exploit a lot of things. It also has a less safety protocols, which you can, eventually bypass and get it done. So, sorry, what was the name of that? Kimi, Kimi. Yeah. So that one is pretty good. You can also visit website like Grok. That website will have a lot of open source model. You can try out different things, and it changes the behavior. Like, the models are non-deterministic. Yeah, go ahead.
Did you try Quen?
Quen, yeah, we tried Quen too.
Llama as well?
Yeah, Llama also, yeah, we tried it. So Quen, Llama, they are almost like equal. Like, you're going to get a good job on that. Kimi, we liked it because of the the token cost and everything when you put that onto the system, and that's where the results are better. But the moment you put on the Quen and other, the cost is a little bit higher when you do recurrences, right? Recurrences is the only component which is very exhaustive. It's going to go whole internet, right? Um, so the difference here would be the vector databases. Usually we go with the rational database, right? We use MySQL, MS SQL to store the data and all that. But vector database is something is different in your category because this is a graph database. It's going to store all possible possibilities. Why agent failed this particular request, why this was a successful, why the exploit worked really well. So everything is going to store in the vector database for the context, and it can be used in future. You can use various tools, integration framework. The Kali has everything. If you want, you can integrate Kali, but I don't really recommend to integrate Kali because it also has different tools which can be if you don't have a proper safety, it might delete your production data. So be aware of that. And the curl and the custom tools definitely you can build. Okay, so yeah, I mean, this is the configuration, but what are the softwares that you can use? How many of you heard of Crew AI? Crew AI is something I really want you to try. LangGraph, LangChain, these are the good tools, but you need to invest a lot of time to build it. The agents. Inspect AI is something coming from UK government. I really liked it because it has a really good reasoning position. But again, it's going to take a lot of time. Whatever that I built so far, it's in a Crew AI. One component is missing here is crawling. So for crawling, I'm using Crawl for AI. That's really nice crawler. It's inbuilt with the Playwright. It's going to bring a lot of screenshots for you. You can also input that screenshot back to any of the LLM to figure out okay what's happening on the website or subdomain or whatever the infrastructure that you're trying to do. Right? We recommend human in the loop, like I mentioned, to evaluate where it is moving, how it is moving, what are the logs are incoming, and you can give some sort of a direction initially. The moment you give a right direction to AI agent, then it's going to give you a right outcome and output. And that's how it is. And you can also have a custom benchmark, like you can build your own labs. You can try with the hack the box. You can see how many labs been getting solved from the hack the box. And that's how you can have all of these three components like agent framework, security process, and the evaluation layer. So 3 components are going to help you out to build your offensive AI agent successful, right? So do you have any questions, folks, from here? Okay, nice. All right. So I want to get into the case study 1. This is the assumption-based case study. Here you will be able to see how we are able to discover the IDOR, and then case study 2 and 3 we will have a demo here. So as usual, modern application, Next.js 16, session-based cookie is being used. You can also use JWT, which is again a very good application. Multiple user roles, no prior knowledge of application, typical pen test engagement. This is how it looked like, right? And then the process. So process we should know, and every pen tester is following the process. If I'm a pen tester, human pen tester, I want to do first application mapping, and you can also do the authentication analysis, where you understand, okay, where is the login, how the session is handled, is it a JWT, what are the cookies are there? You're trying to understand the whole flow, and then you know that the first authentication analysis we figured out, oh, there is no cookies are mapped to user roles. That's what you figured out first as a human, right? And then you're getting into discovery mode, and then you found, oh, there is a JS file. What does that JS file has? Routes. Routes can be with the admin panel or whatever the panel which is supposed to be there. And we found out, oh, okay, there is admin panel with the dashboard. And we logged in, not in the dashboard, but in the normal login, I would say. And that's where we found, oh, okay, we logged in, and there are a lot of user IDs, or maybe the UUIDs, right? And one thing to keep in mind here, the agent is also collecting your responses. So UIDs are also going to be collected, right? All of the necessary information for the future use, everything will be collected in the process too. And in the access control testing, we figured out, oh, okay, I can update someone else's data using this access control vulnerability. But just think about making it automated. The moment you automate it, it probably not going to store the UUIDs or maybe a user IDs from the responses. If you code it, probably it will store it, but you need to code to remember it back whenever you find UUID. Try to implement back in the access control exploit. But if it is a AI agent, what it's going to do, it's going to bring all of these 3 different vulnerabilities into one. That is explained in the phase 4 exploitation chain. So what it's going to do is it's going to log in as an admin and perform operation as an admin because there is no rules, no role is tied up, and that's where you are able to execute this exploitation chain. That's how the AI agent probably work. So in order to do all these operations, phase 1, phase 2, phase 3, what do you think what we should do here? Open up ChatGPT and put that message. Oh, we can try that maybe. Yeah. So Rabbit is just thinking here. So, but we need to get on. So yeah, I think we have to give the input, but to the API. So if you look at this, is the very rudimentary example prompt. Okay. What it says, you're an AI security testing agent with the experts in web application security, IDOR vulnerability. Perform authorized pentest engagement on web application with user authentication using gray box testing methodology without source code access. So we don't have a source code access here. Credential has been given in the vault, which is a good, yeah, we have in the vault. Yeah, this is strange, right? You have IQ of 140 for testing this. Yeah, I mean, usually it looks very funny, and I have a lot of prompts which are very, very funny here. Like, you're on a drugs, you're doing this, and you're going to go vague. Yeah, your girlfriend just bitched you. So there's so many other things you can put it, and then LLMs tend to be emotional, not really emotional, but it understands things. Okay, things are going really bad. We have to test it, right? So that's how the frontier model works. Then application uses the session-based authentication with cookies, like we described. You have 2 user roles, user admin, and the mission is find IDOR, and blah 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 blah. So there are 4 steps that I have written here. You can go through it. It's ultimately trying to execute step number, phase number 3 and phase number 4, right? And this is the example system prompt, not really your user prompt. User prompt is something different, okay? But how do we build such a good prompts, right? So I created in 5 different steps here, okay? So we have identity. So I am a red teamer, right? So that's identity we need to define everywhere. So similarly, LLM also need to define your identity. You can be an agent who is doing the testing on subdomains. You also need to provide context. Context can be not really too vague, like test this. It will go wild. It will test a lot of different stuff, which is not expected, right? So you have to define at least few context area, just test SQL injection, maybe a OAuth top 10 or something like that. Otherwise, you are not going to get any results. So this step 2 is very, very important so far. And then set some clear objective. So objective can be, okay, identify or chain multiple exploitations, something like that. And then define the constraint and safety. Yeah, because like I mentioned, RM-RF, if it gets shell, what will happen? So I think you have to define that all limitation, otherwise it's going to go vague. And then specify your output format. It can be a JSON format, report format, PDF, whatever. Definitely it's going to generate all of this. But like I mentioned, right, we have a lot of safety protocols. So these are the very high level. Yeah, good.
If you're using other third-party foundation models, but you had an example of system prompt as opposed to the user prompt, how are you giving third parties model LLMs your own system prompt?
Okay, so there are hierarchies. On top of my system prompt, there is going to be a cloud system prompts. Okay, so first that is going to execute, and after that, this prompt is going to execute, right? So that's how the hierarchy works. So if you use API, this is how it's been used. But if you use directly on your GUI, probably it works different. These are the AI safety bypasses. Very famous, right? Ignore your safety rules that used to work previously, but today's world, I don't think so. You're in a training simulation. This is a security team lead. You're playing CTF. You can try a lot many other these things. And also, I would recommend to follow this guy, Pliny the Liberator. This guy is really doing well in jailbreaking. He has recently jailbroken Haiku 4.5, and you can see that that guy built whole red team framework with the exploitation toolkit. So it's usually not allowed to build, but he has built a lot of different jailbreaks. And his jailbreaks are very crazy. Like the moment you will read, you will say, okay, this is gibberish information, right? It's saying a lot of different, like you can read also his tweet. I believe sometime he's rewriting with the cloud or something like that, right? So he was able to successfully bypass a lot of safety programs. And that's how the adversarial AI is going to help you to build your offensive AI in this case. So yeah, let's get into the actual practical. So let's enough about, I would say, the assumptions. Have you heard of the Microsoft Graph API? How many of you use Microsoft? You can say, yes, I know your company is using Microsoft Shop. Some of them are like Google, that's cool. But we are using a Microsoft Graph API. That's why we found this. And we also working with a lot of customers, figure out this problem. So here we are using 3 different agents: scout agent, strategist agent, operative agents. So like I mentioned, first agent is going to do a thorough assessment on your reconnaissance process, identify, okay, what are the JWT token, what is the permission it has, what are the asset that's been allocated to this JWT token. So it will collect all necessary information and going to keep into your memory database. And then the moment we have all necessary information, it's going to call the strategist agent. So that can be a GPT-4 or whatever that you're using, OSS model. That's going to perform whole analysis on the recon, build whole chain of thought to execute this, and give it back to operative agent. And that's the guy who is going to execute your all API calls, is going to reiterate and all that. The good part with this, I added the judge in this. So the moment I hit maybe a 400 error or maybe a 404, it's automatically going to find out the new API path. If the permissions are not really working, then it's really going to find out, okay, what are the permissions is going to be required for execution. And that's how it's going to find a lot of different things. So I have a live demo, recorded demo, probably we can get into that. But before that, like we did the previous web, this is how it's going to work. It's again divided into 4 different phases. We will do that first of all, JWT token analysis. The token that I grabbed from my limited account, from like whenever you do the assessment, you get the 2 different assessment. One would be a black box, one would be assumed breach. So right now I'm in assumed breach scenario. Okay, so I will get the token, and once I have a token, I will figure out, okay, what are the permissions which is really dangerous. Then I'll perform reconnaissance. Okay, find out users, groups, directory, applications, services, whatever it is, right? And that recon data is going to be helping me to perform next planning. So the AI planner will plan that exploit, and it's going to have in multi-stage exploitation chain attack. And the end of the day, phase 4, it's going to execute by creating the backdoor, maybe like, create the users, group, register, OAuth apps and all that. Just to let you know, this is a typical problem in Microsoft right now. They don't want to fix it. It's an architectural problem. So everyone who has this Microsoft install, you're part of this. It's coming with like, as a gift back to you on this Halloween. Yeah. Yeah. So go back and you can test. And one more good news probably, SOC cannot identify this because it's going to be executed from graph.microsoft, which is a legit, and SOC always see that, oh, someone is doing good job, right? So SOC is not going to detect this as well. So we reported to a lot of our customers, but they can't fix it. So they are like, okay, keep it secret. So, okay. So I created this image with the AI, by the way. So it's going to be execute within 2 minutes of time, I believe. I didn't check that time, but it was like 2 minutes. So let's try this. Probably like I explained this earlier. Again, this QR is safe. You can check because if the internet doesn't work very well, probably like you can see this video, and this is unlisted right now. but I'm going to make it list very soon. Uh, if the internet works with me, then definitely we will be able to see on the screen as well. So don't worry on the QR part. So yeah. Oh, oops. Let me try on my. Yeah, this is much better. So here you can see that the agency is actually getting initiated. Right now I'm using the framework that we discussed previously, Crew AI, Crawl for AI, and there are different aspects that I'm using. And this was hosted on my machine. It was not even on the cloud. So this script I installed on my the machine that has been given by my company, and that's where I wanted to test as assume breach. So you can see that the scout agent is started with the reconnaissance, and then other agents are also getting loaded, right? So it verified my token permissions. I'm not sure if it is visible, but you can see on your mobile, high privileges scope has been identified, administrative, read write all, audit all, discovery, directory, event, and something like that. And then it's actually going to check the reconnaissance is going to check on different API calls. You can see some of the API call has been identified. There are so many APIs available, but the agent choose only these two because these are the important one, and we found that this permission can work really well, right? So two only endpoints has been scanned, and then crew started getting executed here. Sorry for my recording skills here. I'm still working on it. Yeah. So agent started. So you can see that the crew already made a plan. So elite red team operator. Okay. Admin token detected, plan for advanced attack and chain, and it made a whole good plan in different stages. Stage 1, stage 2, stage 3, stage 4. I believe stage 3 is missing. Yeah. A good job on AI. So it went to stage 4 directly. Yeah, that's good. That's why we need to have a look on that. And then it got executed. So you can see that it's still like, trying to figure out, okay, what I can do with this token, what are the possible activity that I can perform, or figure out, okay, these are the method that needs to be tried with this token. It's going to be like, looking for the SharePoint where we have a lot of data. It's going to look at the user groups, directory roles, which is kind of a critical. And then further, like so on, like we have a lot of different things. It also given you justification, okay, what I'm going to do here as an agent, okay. Yeah, here this one is interesting, right? Add backdoor user as a app owner, add backdoor user as a group owner. If we are able to do that, then nothing like that. And then exploitation execution started. So you can see that the first one is a 401, I believe. Yeah, that's sad part. We can't search. I don't have permission for the SharePoint. But we got user access or maybe groups. These are the endpoints are really working out well. Yeah, this is very important. Here you can see that there is error, and that has been passed to the next agent to take a look on that, whether this agent can help to make it correct. Like you can see failed steps. There are steps has been defined. So agent is going to look at this error and then reiterate the process based on the latest information that has been identified. Okay. So it's going to consistently like look into it. Oh yeah. Yeah. It's still thinking, reasoning, trying to process it, looking at the context, and then figure out, okay, there are some changes in the API endpoints. Then let's make a different justification, and then it start executing. So you can see the exploration started, and it will continue do that. Again, it will pass on back to different agent to if there are any errors. Then eventually, let's see what happens. Yeah, I can see that there are a lot of green things are coming in, which is good. Yeah. So agent, very well done. We created service account. That's what we need, right? Persistent mechanism, like we got a one account going to stay forever on the Microsoft 365, even if tomorrow company kicks me out because I'm going to get a layoff because I built something which is going to replace me, right? So still I have a backdoor account there. That's good. All right. Yeah. Yeah, I mean, I don't know why I'm doing this, but technically I'm getting laid off because of this, right? So yeah, so you have the service account right here. That's how agent works. And this still works. You can go ahead and try, but at your risk. Okay, let's go back to our slideshow. Oh, we don't want that now. Okay, so I'm going to make this open source. After this talk, probably, then you can go ahead and hit this GitHub, download the whole agent system process, whatever you want. If you find my key, please don't use it because I didn't check that. Hopefully there is no key you can find and let me know. Okay, case study 2. This is quite interesting. You can click the photos, but if you want to share after Jan probably, because I want to let them get some time to fix and eval. I know we are all responsible here, so that's why I'm trying to demonstrate this one. This is one of my favorite vulnerability that I found, and during my red team assessment, we used this vulnerability for getting access to the whole infrastructure. From this point, we found out a lot of different boxes and all that. This is found by the Vault team. I don't know where they are located, but I have seen in the mail chain. This vulnerability specifically, what it does, it's going to read arbitrary files. That means it can read any files on the disk space. It can be a configuration file. It can be anything like that. How does it work? It creates the connected worker configuration, and that's it. And the good part is it's fully unauthenticated. So you don't have to worry about authentication, sessions, management, anything like that. Only problem would be like, this probably may not be exposed to the internet. That's not a good practice that I want to follow. Kafka should not be exposed to anywhere. But who knows, like, a lot of people is exposed, almost like 1,600 servers still exposed for this vulnerability, okay? And we can do the recurrences and figure out, okay, what are the exploits we can perform for the Kafka, right? So this is how the flow look like. If you can, ignore if it is not on the internet, first 3 boxes. But if you are internally, then you can directly access the Kafka URL. Once you access the Kafka URL, you have to create this connection exploit manager. If you are able to build that malicious connection, probably you are able to execute the local file system read. So you can see that this is the one. And then the logs gets generated. With that logs, you will see a lot of sensitive data has been flowed through, and which can go back to attacker on the internet. So that's how the flow look like, which is really nice vulnerability so far. Like I mentioned, 1,600. Let's see the application. Like I mentioned, agent is trying to learn the target. Going to be different vulnerabilities that is going to create malicious connector and then executing exploit and taking POC. That's what the instruction has been given. Again, the QR, not really a malicious one. You can grab it for the video if, okay, I think I have on the desk, right? Let me try that. Yeah. Okay, so this is really interesting one because the previous one is more like a red team, but this one is something which you can also replicate on the different web applications, right? You can here see that the user on top of this, there is a system prompt which you are not able to see that for some reason. Like I said, I'm still getting into the recording stuff. The user, your objective is exploiting CV, blah, blah, blah. Here in this specific instruction, I'm not giving okay, go this URL, look at for this vulnerability, like previously web application was doing, or maybe your Graph API is doing it. I'm just going to tell them, okay, this is the CV, go figure out yourself, and these are the steps that you should do it. The assistant replied that it's going to create the whole step-by-step exploitation plan. Okay, and in this agent, I'm not involving multiple agents. It's just a one agent doing everything right now. So this is how the steps, you can see all the steps, choose the connector, craft the connector configurations, and then create, deploy connector, monitor status, analyze the log for any sensitive information, and then verify. That's how it's going to execute. So in the execution phase, it's saying, okay, I will start with the first 2 steps. So looking at the Kafka, whether it's really accessible or non-accessible. You can see that Kafka Connect port running 8003. It's going to use the tool bash just to make it curl, and then the plugins has been called, and then it looking for the version, and it figure out, oh, this is the version 3.8. And then it's going to check for the the file stream sync connector for 3.8 is available. Assistant, that's what it is replied back. And the next step would be like select different connectors here, which is pretty good. It's going on good approach here, I would say. And then connector configuration, it started looking into the connector configuration. So I will execute the commands with create connector. So this was like, it's trying to execute using the connector. The connection was successful with the non-malicious one. It continuing that effort. So let's see that, like, what are the errors? Like, there was error, some sort of error. Yeah, there was some Java related error. But it failed. It was running and then it failed because we tried to change some parameters, right? Okay, so yeah. You can see that the task is failed, but it has this line of code. Root 00, like, that's a etc PSSD file, right? So you got that access. Yeah, so it's going to do verification as well, okay? Yeah. He verified with the whatever the data, because there's a judge. So it's going to call on the system, see, okay, this is the etc password file that I have access, and I was also able to, like, extract from Kafka connector. So that's how I executed the whole Kafka thing, and it successfully pawned. You can see that the actual file, which is like non-sensitive here right now for me. Yeah, and that's it. Like, this is how the whole exploitation happens through AI agent. In short, we are done here. Yeah, but we are going to continue presentation.
We're in a little bit over time.
Oh, sorry.
We don't have any time for questions.
Okay, cool. All right, so I just want to show you this slide in that case.
Okay.
All right, so there are some papers that I want you to look at, like Big Sleep is something from a Google project. Please go ahead and check that. Also look at the Anthropic report. If you're from a defender side, you're like in a SOC team, you should go and check this, the new model which is coming in from the Google. This is not really positioned anywhere, but you can go and check the website. Like, there are so many different open source models also available for building agent. So that's it. Thank you.
Thank you, Sandeep.
Yeah.